everyone, have you ever wondered about that how do the scientists know about the structure of any unknown chemical compound? How do the scientists know the composition, temperature, density and other important physical processes of an astronomical object which is far in the universe? How does MRI machine give the images of the soft tissues present deeper inside the body? And have you ever thought that how do the scientists get to know about the atomic arrangement in the metals? Also, how do the environmentalists get to know the constituents of pollutants? The answer of all these questions can be solved with the help of one common technique, that is spectroscopy. So friends, today we are going to discuss spectroscopy, and in this particular module we will be discussing the basic concepts of spectroscopy. So what is spectroscopy? Spectroscopy is the study of interaction of the light. Light means electromagnetic radiations and the matter, by virtue of which the structural identity of the matter can be identified. So how many types of spectroscopies can be there? Spectroscopy can be of the two types, that is absorption spectroscopy and emission spectroscopy, and even these absorption and emission spectroscopies may be of two different types. Absorption spectroscopy may be atomic absorption spectroscopy, it may be molecular absorption spectroscopy. Similarly, emission spectroscopy may be atomic emission spectroscopy and molecular emission spectroscopy. We will be discussing the details of these spectroscopies a bit later, but before that we must know the interior of the spectroscopy, the gist of the spectroscopy, what is the basics of the spectroscopy. So if we really wish to explore the depth of the spectroscopy, then we need the support of quantum mechanics. Yes, you rightly have heard quantum mechanics. Don't be afraid, students. We will be doing a bit of it. We will be taking a bit of it. So why do we need quantum mechanics to understand the spectroscopy? Because the understanding of nature of the light and matter, these both are thoroughly taken up by the quantum mechanics, and these mechanics include complex mathematical analysis. So what is the heart of spectroscopy? The heart of spectroscopy and the significance of using quantum mechanics lies in the fact that energy of specific electromagnetic radiations lies in the order of energy difference between the two energy states of the matter. So we need to understand these two things separately, and then we will be seeing how these two are related. That how energy of the electromagnetic radiation interacts with the energy difference between the two energy states of the matter. So before we discuss this equivalence, we must know what are electromagnetic radiations. Don't worry, I know that you know a bit about it, but let us discuss it a bit about it again. So as we know, according to de Broglie, the nature of matter is dual. Yes, we know that matter or electromagnetic radiations, they both have dual nature, that is a photon. A photon means a particle nature, and also they have energy but no mass. The second type of the nature that matter or light exhibit is the wave nature, and as a wave nature, as we know that every wave have characteristic wavelength and frequency, so the same rule applies over here. The electromagnetic radiations have wavelength and frequency. Also, the very important thing because of which they are named as electromagnetic radiation is this, that they have electric and magnetic field oscillating around them in space and time. And the last but not the least about electromagnetic radiations, as a wave they travel with the velocity of light. So this is all about the electromagnetic radiations. As we just have discussed that spectroscopy is the interaction of electromagnetic radiations with the matter. So firstly we need to understand what are electromagnetic radiations. So this is the gist of electromagnetic radiations, but we know that these electromagnetic radiations are of various types depending upon characteristics, that is wavelength and frequency. Yes, I know you know this kind of spectrum, you probably have seen this earlier also, but again let us discuss a bit about it. We can see that there may be different types of electromagnetic radiations depending upon their important wave characteristics and the particle characteristics they have, and we know that the wavelength of these electromagnetic radiation is varied and it depends upon the nature of that particular electromagnetic radiation. So if we see this spectrum, and you can read this spectrum in either way, you can come from left to right or you can come from right to left also. So if we see, if I am moving from left to right, it starts with the radio waves, and these waves are having very long wavelength. These radiations are being utilized in your radio towers and of course in some kind of spectroscopy. We will be discussing that later on. So moving from radio waves towards the right, we have microwaves, then we have infrared radiations, visible radiations, ultraviolet radiations, X-rays, and then finally gamma rays. So every electromagnetic radiation is having its characteristic wavelength and energy. Please mind it. Now, how do these electromagnetic radiations interact with the matter? You all know, I know that in your grade 9 or 10 you have read that how light interacts with the matter. The same we are discussing again. Light may transmit through a particular matter. The phenomenon is called as transmission. It may get reflected, may get refraction, diffraction, absorption and scattering. But we need to understand about the absorption, because we are saying that spectroscopy is the interaction of light with the matter. Until or unless the light is not reached to the matter, how will it interact? So the important phenomenon that we are going to see here is absorption. Even your absorption spectroscopy or emission, the first thing which has to take place is absorption of the radiation, right? So keep this thing in mind.